Hi, thanks for joining. Today we're going to be doing our daily recap for days 5 and 6 on my CKA exam prep. Now, for the first summary that we will go over on the learning content that I went over on day 5, is specifically targeted towards the application lifecycle management. Now, usually when I do these slides, they are in kind of the form of question answer. So first question is, what deployment strategies does Kubernetes support and how do rollbacks work? Kubernetes supports rolling updates as a default strategy, which gradually replaces old pods with new ones to maintain availability. You can roll back to a previous revision using kubectl rollout undo and view rollout history using kubectl rollout history. How do you configure application behavior at runtime? There are three methods. The three primary methods: environment variables set directly in the pod spec, ConfigMaps for non-sensitive configuration data that can be mounted as volumes or injected as environment variables, and secrets for sensitive data like passwords or API keys. Secrets should be encrypted at rest in etcd for production clusters. Now, what are the multi-container pod patterns and when do you use them? The three main patterns are sidecar, helper containers that extend the main container's functionality, like a log forwarder; ambassador, proxy container that handles external connections; and adapter, transforms the main container's output to match expected formats. Now, apart from containers, you also have init containers. So for init containers, there are two types: traditional init containers that run to the completion before app containers start, and sidecar init containers that start before app containers but continue running for the lifetime of the pod. How does Kubernetes handle application scaling? Well, you have horizontal pod autoscaler, automatically scales the number of pod replicas based on CPU, memory, or custom metrics; and you have vertical pod autoscaler, VPA, adjusts CPU and memory request limits for existing pods. You can also manually scale deployments with kubectl scale. HPA requires the metric server to be installed in the cluster to collect resource usage data. Now, on day 6, which today is my day 6, the topics that I went over were around cluster maintenance. So the first question on that topic is, how do you safely perform OS upgrades on a cluster nodes? You use kubectl drain on the node to safely evict all pods from a node before maintenance. This marks this node unschedulable and gracefully terminates pods, rescheduling them on other nodes. After completing the OS upgrade, use kubectl uncordon the node that you drained prior to mark the node as schedulable again. If you only want to prevent new pods without evicting existing ones, then you use a cordon command, which is kubectl cordon instead. Now, how do you upgrade a Kubernetes cluster? Now, I want to preface that there are many ways to upgrade Kubernetes, but this is the one that was gone over during the course. So to do it, you do a cluster upgrades, follow a specific order. You upgrade the control components first, then worker nodes. The process uses kubeadm. After upgrade, the kubeadm tool itself then run kubeadm upgrade plan to check available versions and compatibility, followed by the kubeadm upgrade apply to the version that you want. So in this case, in the course, I went from 134 to 135 to upgrade the control plane. Worker nodes are upgraded one at a time by draining them, then upgrading kubeadm, and then kubelet, then unconfigured them. Now, I want to mention that in this particular section, you actually have to log onto the host of the worker nodes. The same with the control plane. If you have more than one, then you have to go through each one before you go to the worker nodes. Then you can only upgrade minor versions at a time. So again, in my case, I went from 134 to 135. Now, after this Kubernetes upgrade, we also did a backup and restore using etcd snapshots. So to do that process, you use etcd snapshot save to create a backup of the etcd database, which stores all cluster state. To restore, first stop the API server, then use etcd snapshot restore to create a new data directory from the snapshot, and then restore after. After restore, update the etcd static pod manifest to point to the new data directory and restart the control plane components. So the remainder of the control plane components. Now, that's all I had for day 6, and that's all I had for this presentation. Thanks for joining. Hope to see you in the next one. Bye. Take care.